Anybody know how we might want to start this one?
Not
Yeah.
oh, and then you're gonna say like plug it in or something like that, or yeah, synthetic division, right? Yeah, exactly. So synthetic division is when we did this little box thing, right? And you write the numbers in front, the coefficients there, cross. You want to make sure though that it goes in order. So this is a third power, a second power, a first power, and then no power. So you're always going to make sure it goes in order. Now you got to put a placeholder 0 in there. But this does go in 0. So we're going to write out the coefficients: 1, -1, -10, and -8. And then we write a number outside that Sanjay was talking about there. And it's not 2 though, it's going to be -2 because you want to actually set this equal to 0 and solve it. You get x equals -2. So that's the number that goes on the outside. So from there you do your synthetic division steps, which are you bring down the first number, you multiply, atom, multiply again, 6, atom, we get 4, multiply again, we get 8, atom, we get 0. So then the question is this a factor? Yeah, it's a factor because this number is 0. This is called the remainder. This is 0. Okay. Is that? So if it was anything other than 0, it would not be a factor. Okay, next one. We're switching to angles now. Give the angle measured by 54 rotations clockwise. So basically what you got going on is start here and you go around 54 times. Alright, what angle would that be? Yeah? Okay, almost right. Yeah, almost right. So you did 54 times 360, right? Each revolution is 360 degrees. Okay. So yeah, if you do that in your calculator, 54 times 360, you get 19,440. Why is that almost right? Yeah? Uh-huh. Yeah, so we're going to say Logan? Okay. Yeah, so when we did angles, we drew them in like this way was a positive angle from there to there, and that's counterclockwise. So positive is going to be counterclockwise, and then clockwise is actually negative. So we do have to throw a negative on it to run that one. The next one asks us about a coterminal angle. Alright, so a coterminal angle means an angle that ends at the same spot. What are we going to do here to figure that out? Yeah. Exactly, yep. Add 360 until we get a positive angle, right? So we add 360. We get negative 440. It's not positive yet. So we add 360 again. We get negative 80. Not positive yet. So we add 360 again. And we get 280 degrees. The next one, we've got some trigonometry here. The good thing is on your reference sheet, you are given formulas. All right, here's your reference sheet. So if you forgot the trig ratios, they are given to you. And we're supposed to use this triangle to find sine, cosine, tan of A, and then all of your inverses. The only thing is we don't have this side here, So we gotta find that first. This should have a box right here. It doesn't, but it should. It is a right triangle. So given that it's a right triangle, how are we gonna get that last side? You're right. It is a 3, 4, 5. It is 4. You're right. If you didn't know that it was 4, yeah, you would do the Pythagorean theorem, right? So this side opposite is a. So you would say a squared plus 3 squared equals the hypotenuse squared, 5 squared. And solve for it, and you will get 4. You're right. That is a special type of right triangle. So you get 25. You subtract the 9. A squared is 16. So A is 4. So that's how we get there. If you didn't know that it's a 3, 4, 5 right triangle. This one's used a lot. Okay, now from here, we're asked to find all of these in relation to A. So A, we're asked to find the sine of A. I always like to write out SOHCAHTOA. And you can use the ratios, yeah. So sine of A, so make sure you start at A as the opposite, which is 4, over the hypotenuse, which is 5. 4 over 5. The cosine of A is adjacent. This is the adjacent side. It's 3, and the hypotenuse is still 5. And then the tangent of A, opposite, which is 4, and adjacent, which is 3. Make sure you know the hypotenuse always stays opposite the right angle.
It disappeared. It just,
Okay.
just like, it just like 1 second.
Alright, now the other ones, you can look up the ratio, but all of them are just flipped reciprocals. So cosecant is 5 over 4, secant is 5 over 3, cotangent is 3. Okay, the next one, we're asked to find the tangent of theta if theta's in standard position at the point with coordinates 4, 3 lies on the terminal side. So what we're going to do is graph 4, 3. 1, 2, 3, 4. And let's go ahead and draw a line here. This represents the angle. So the angle would be this theta down here. So that's the situation we have going on. What we want to do is just make this into a right triangle. So this triangle here has 4 as this length, right? It's the x direction. And the y is 3. So we get a triangle that looks like that. And we're supposed to find the tangent of theta. Well, theta is here. The tangent is opposite over adjacent, which we've already got. So it's 3 and 4. If we needed to, we could find the hypotenuse, right? 3, 4, 5, right? That's a 3, 4, 5 rectangle, yeah.
Y exam also exclusively used the 4, 5, right?
No, sorry. Yeah.
Can you like label which one goes to which section?
Sure.
Yeah.
Or like at least
No, it's
break
just a
it down
list
into
of all the
sections.
answers, but you don't know which is which.
Okay. I'll just give you a bunch of A's, B's, and C's and D's. Right? You gotta figure it out.
I mean, you can still use that. You can count how many there's supposed to
I think
be.
you would miss more actually doing that, because then you would like think you're missing an A, and C would change that when that's right. All right, so the next one, triangle FGH. So I would always suggest drawing the triangle if it gives you a triangle. It does not say it's a right triangle. Actually, sorry, it does say it's a right triangle. The next one says it's not say that. This one does say a right triangle. So draw a right triangle. And it specifically says that G is the right angle. So I'm going to call this FGH. And put everything on there. Little g is opposite of big G. So little g is over here. Big F is 25. And little h opposite over here. And we're asked to find little h. All right, so anybody have any ideas? So it's kind of like a hint. Anytime you're going to do these triangles, you're going to be using what we used for triangles, which was law of sines and law of cosines. Okay? So that's kind of what you should be thinking. We're going to use one of these. Law of sines is always where you want to start. You want to see if you can get a pair that matches. Like you want to get a big A and a little A, big B and little b. You want to get a pair that matches. Now we don't have a pair yet. G's, we don't have G's, we don't have H's or F's. But we could actually start, we do have a pair. And we can find this H pretty easily as well, right? Because we know 90 and 25. So we got 180 minus 90 minus 25. That's going to give us big H, just 65 degrees. And then we take the pair that it gives us. Since this is a right angle, we know that it's 90. So the pair we're given is G's. So we're going to do the sine of G, like sine of 90, over little g, which is 15. We're trying to find little h, so we need to include big H. So sine of 65 over little h. And then we're just gonna cross multiply and solve. So we do sine of 90 times h, which we'll just leave as sine of 90h. And 15 sine 65. And then we just need to divide by sine of 90. And then we can just plug that in. Two things. Make sure though on your calculator when you do this, we're talking about degrees. So make sure that your calculator is in degrees. So just double check this, hit mode. It should also be in function mode if you haven't changed it to function mode yet from sequence, because there's no sequences. And then we want it on degrees for now. Talking about degrees. And then we can just type it in. So 15 sine 65. So make sure you close your parenthesis there to enclose the sine 65 divided by sine 90. You get 15.59. So h equals 13.59 to 13.6 degrees. Another thing that you always, sorry, that's not degrees, that's that side. You always want to make sure it seems reasonable. So a thing to remember is bigger sides are always opposite bigger angles. So big G is the biggest angle, and it's 15. Little h being 13.6. Well, that seems reasonable, right? It's less than. And 65 is kind of proportional to 90, so that seems reasonable. So make sure that's not bigger than G, because then you'd have an issue. All right, number 20. So with this part, what do you think we're going to want to look at? Where should we look for help on number 20? Those numbers look familiar at all?
That's the number they told my dad.
Yeah, he was right. So the unit circle has these 1/2, radical 3/2, things like that. So this is what we want to refer to. Also given, these are important right here. You're given a sine and a cosine. It says that the sine is y and the cosine is x. That's going to be important as you solve this as well. I wish this actually would have used theta instead of sine. I need to change that for next year. Change that just because the sign makes it a little confusing, because when we're asked to find the sine of where the sine of x equals 1/2, what this question is asking is the sine corresponds with the y. So it's saying, where is y equal to 1/2? That's basically the question it's asking. Okay. Sine refers to y coordinate. So y has the y coordinate 1/2. And if you just look around the coordinate pairs, you can see right here, right? But that's not the only answer. There also is a y that's 1/2 over here. So you gotta make sure you get all of them. The other ones are gonna be negatives, so those are not good. But at 30 and at 150, and let's also write the radian equivalent too. So at 30 degrees slash pi over 6, and then at 150 degrees slash 5 pi over 6. Both those places, the sine is 1/2. See if you can answer the next one. See if you can find where the cosine is negative radical 3/2. I guess I should put it up here. Cosine is the x, so you're just looking for where in the case. Like the last one, there's two answers here. 150 and 210. 150 degrees, which is 5 pi over 6, and 210, which is 7 pi over 6. All right, now the tricky one is going to be the tangent. The reason why is because if you look for a negative radical 3, you're not going to see that anywhere on the unit circle. You got to make it into that. And you also might want to look at it. Tangent is the y over the x, it's the sine over the cosine. So what you're looking for is a place where if you put the y over the x, you're going to end up with negative radical 3. So what I would do first is narrow it down a little bit. So which two coordinates could it possibly be in? Which quadrant should it possibly be in? Where could the tangent be negative? Close. Second is 1. The third one, it would actually be positive because you'd have a negative over a negative. Right? Yeah, second and fourth quadrants are where a tangent could be negative because you got to do an x over y, a positive over a negative, or vice versa. So it's narrowed down to these. Okay. It's obviously not going to be anything with the zeros and the ones, right? There's no way you're going to get a radical 3. It also is not going to be the middle ones, right? Because if you have a radical 2 over radical 2 over radical 2 over radical 2, it's just 1, right? So it's going to be those. So basically what we've narrowed it down to, it's either got to be this or this, and then along with that, this and this or this, right? So let's just try one. Let's try the first one. That one, if we're going to do the tangent there, it's going to be the y over the x, so radical 3 over 2 over negative 1/2. Now we're going to simplify it and see if we end up with negative radical 3. There's really only two options, right? It's either this or it's flip. So when we do this, we keep change flip, keep the top, change it to multiplication, and flip it. The 2's will cancel. And then we'll have a negative radical 3. So that's what we're looking. That's good. Okay. I want to show you the other one just so you see it. just a refresher on how it works. If we chose the other one, 1/2 over negative radical 3 over 2, we still keep changing split. It would be a half times 2 over radical 3. The 2 still cancel. We'd have negative 1 over radical 3. But we never leave a radical on the bottom, right? So we then, it's called rationalizing. Multiply by radical 3 over radical 3. So we get negative radical 3 over 3. An easy way, I guess, to kind of remember it is if you have a radical 3 on top, you just end up with radical 3 at your answer. Easy way to remember. If the radical 3 is on the bottom, then you end up with a 3 on the bottom. You can always verify, double check. So this is not what we want, right? We wanted that one. So our answer then would be this one here. So 120 5 over 3. And if you just follow that along, over here, you get the same one here. It's just the negatives in the opposite spot, but it would still work for you, right? So 120 and 300. 20, which is 4, 5, 3. And the other one was, sorry, yeah, 2 pi over here, sorry. And then the other one here is 5 pi over. Those are good answers. That section is basically, do you know how to read and use the unit circle? All right. Here's another triangle. Says we're given a triangle, so we should draw a triangle. This one does not say a right triangle, so we just draw any triangle, call it ABC. And let's plug in everything they give us. Big A is 34. Little a opposite of that is 13. Big B is 28. We want to know little c. Okay, if we're going to know little c, we need to know what big C is, probably, right? We do have a pair. You can see we got big A and little a. So we're going to use that. We're going to use sine of 34 over 13. That's our pair. Well, we got to have something to match it up with. So we're going to need sine of big C over little c. Big C is not hard to get. We just use the fact that there's 180 degrees in a triangle and subtract these two. And then we get 118. So the sine of big C, sine 19 over little c. We're then going to cross multiply and divide. Sine of 34c equals 13 sine of 19. And then we just divide. Doesn't tell us what the round to, so it's 20.5. Usually makes sense. So A was 34 and it was 13, so this should be significantly bigger, and it is 118 opposite of 20. That makes sense. Biggest thing opposite of the side. I've got one more of these, so go ahead and draw that. The label, little b is over here. C. Okay. So we call this side angle side because that's what we're given, right? Side angle side. This isn't going to work with law of sines because we don't have a pair and there's no way to get a pair, right? We don't have a pair of any of them and we can't figure out either of these other two angles. So if we can't use law of sines, we go to the other option, which is law of cosines. We have right here. Basically how these work, to refresh you, these first and last ones always match. So the little a and the big A match, and then you get the other two sides squared and multiplied, and then minus 2 times the other two sides. We're asked to find little a, so we're going to use the one that has little a squared equals. Little a squared equals little b squared, which is 5, plus little c squared minus 2 times a b. Use the cosine of big A. Actually, sorry, we got that one. That's the number. 6. Alright, now this one's not bad because all we really have to do is plug it all in. If we're looking for the angle, then we would have to, if you guys remember, like subtract this up over and then divide by this. And then do the inverse cosine. So this one though, we can basically just plug it in as it's written. 5 squared plus 6 squared minus 2 times 5 times 6. Here's the cosine of 46. And we get 19.3. You might be thinking, well, that seems too big. That's okay because we have to take the square root. So I'll do that. Square root it. Second square root, second little s. And we get about 4.1. That seems reasonable considering the other ones. The next 4 or so problems should be pretty easy points, I think. 23, we're asked to change this radians into degrees. And you're going to be given the formula, essentially. I'm going to do that. Radians to degrees is right here. It says 1 radian is 180 over pi degrees. If you remember, you're just either multiplying by 180 over pi or pi over 180. So here it's telling us that a radian is 180 over pi, which means we're going to multiply by that. We're going to do 2.45 times 180 over pi. So make sure you use the pi symbol, don't type in like 3.14. So you get 140.4. You could also see a problem like maybe it's like 2 pi over 3, and then you got to convert that times pi over 180. If you see something like that where it has it in terms of pi, you would then just cancel the pi's, so then it would just be 2 times 180 pi. All right, in the next one, we're supposed to change this degrees to radians, so that's going to be flipped. We're going to do 190 times pi over 180. It says leave it in terms of pi, so we're not going to be multiplying it. We're going to write it as 190 pi over 180. The zeros cancel. And then we're left with 19 pi over 18. And that's as good as we can do. page. The next two are going to be pretty easy with the formula sheet as well. We did a delta math over these where you had to find like sector area and arc length. So now we're finding like sector pizza. So the formulas are given to you. So these are really easy. We got arc length here, which is the first one. That's the S. And just to refresh you on what an arc length actually is, too. It looks like this. If you got a circle, the radius here is 10. And it says the central angle is 20 degrees. So like this is 20 degrees. The arc length is this distance from here to here on the outside of the circle. So the curve of arc length. Okay. So that's what we're computing. And we're given the formula for it right here. Just theta over 360 times 2 pi r. This is just a portion of the circle times the circumference. The S is 20 over 360 times 2 pi times 10. .49 feet. Seems reasonable. It's a pretty small little part there. All right, and then sector area, also pretty easy. It's just going to be the angle over 360 times the area, which is pi r squared. So, and the sector area represents like that shaded in part there. This one will be A equals the angle over 360, 40 over 360, times pi r squared, so pi times 5.2 squared. As an area, it should be like units squared, inches squared. So again, those last four are pretty easy, right? Okay, we got four more in there. Next one is the equation of a sine function. I did give you a little bit of insight on this one on the formula sheet here. This box here talks about sine and cosine graphs. We did a few like Desmos and delta maths on these. This is like their general formula: y equals a sine bx plus c. You could technically have a number inside of here too, but we didn't do a lot of those. Those are called phase shifts. And then the other important thing is that the period is 2 pi over b, and b is 2 pi over period. So the A represents what's called the amplitude or the height. The B is how we find the period, and then the C represents the shift up or down. So let's see if we can write this equation. It will be y equals, amplitude is 5, so it's going to be 5 sine. And now the B is the next thing we need. The B is not just 6 pi. That's not the B. B is 2 pi over the period. So 2 pi over 6 pi. The pi's then wipe each other out. To the left over third. So that's another B. 1/3. Now for this in parentheses x. So B. And there's no shift up or down, so that's it. 5 sine of 1/3 x. If you wanted to, you could view this on your calculator. You just are going to want to change it back to radians. So if you wanted to type this in, 5 sine of 1/3 x You can see what it looks like, but it won't look like much unless you put it in radians, because degrees is going to stretch out a lot. So just make sure you move it to radians if you're going to do that. All right, 28. Write a cosine function. Similar parameters here. Y equals, we got our amplitude is 3. Cosine. The b is the same, 2 pi over the period. So b is going to be 2 pi over 2. We keep the top, change the multiplication and flip it. 2 pi times 2 over pi. Pi cancel. This becomes 4x. This does as a vertical shift. It should say really up 1, I suppose, but it's a vertical shift of 1. And then our last two are on trig identities. What trig identity are you going to use to verify this? You are given trig identities here. Any that you'll need right here. Which one, what are we going to replace in this? Well, what with what? Yeah, swap out tan with sine over cosine. Generally, a good strategy is changing things to sines and cosines. So we make that swap. And then see that the cosines cancel. And we end up with sine x equals sine x. And the last one, this one's a bit challenging. Just think you can figure this out. And then try. Give me a few minutes to try to figure it out.
Beautiful, like the
Oh yeah. Yeah.
What are the percents do?
Huh?
What are the percents do?
Yeah. You'll get a single trig function. Yeah, you get a single trig function. So the answer is tan squared. The tricky thing about this one is you don't necessarily want to replace everything at the outset. You do want to replace these tans and cotans. They're inverses of each other. But you don't want to touch this one just yet. The reason why is if you do kind of play this out, secant squared x, tan is sine over cosine, and cotangent is cosine over sine. Those are inverses, so they wipe each other out. They don't leave you with nothing, though. They leave you with 1, right? So you're left with secant squared x minus 1. And then that should kind of just like trigger, there is like some formulas that have squareds and 1s. And if you look here, secant squared is over here. If we just subtract this 1 over, we get secant squared minus 1, that's tangent. That's a bit challenging. I don't think you'll have one quite that hard, but you should be able to do that.